Good morning. Hello. You guys there?
Yeah, we're here.
Okay. There you go. There's your problem. What's your problem? Here it is. Store session. Good morning, everybody. Anybody else get up today and say, "Oh, I don't want to do this today"?
Kind of.
Yes.
Not me.
Back and excited for math, but because I have to return a bunch of stuff and I haven't packed everything up yet.
Yeah, you know, often we wake up and we say, "I don't want to face today," and then you just do. 1 foot, that's where the line 1 foot in front of the other comes. 1 foot in front of the other. And then some mornings you wake up and you can't wait to face the day. And that's just the reality of things. Only 34 participants.
One of my favorite comedians did a bit about the postal office. We need to know the weight and the girth. And he just decided to make it up. The girth is 3. 3 what? Girth units.
Yeah, when I saw that, I knew the word, but I didn't know mathematically what it was until I read this problem.
Oh, I estimated it.
Okay, I just sent myself the next lesson, but tomorrow we're gonna have a quiz. It won't be worth any points. It'll just be for you guys to check. We'll quiz and then we'll grade it together. We'll go over it together and it'll give you an idea of where are you at? Would I be able to do this if I took the test today? So it's just purely for feedback, which is what quizzes.
Does it affect our geometry grade?
No, it's no points.
No, I know, as in like the real test we have next, is that gonna go into our geometry grade, or would we have like a separate?
No, it'll go into your geometry grade.
Okay. Because in the end, isn't it not geometry anymore? Isn't it algebra 2?
It's math. It's all the same thing.
Okay.
Is there not geometry in this problem that we're working on right now? It's a fusion, isn't it? All right. Well, it's time to talk about this. So,
So what do they specify as girth?
the girth is the is that square cross section. It's the perimeter of that.
Oh, I see.
Let me read that problem out loud. A U.S. Postal Service guideline states that for a rectangular package like the one shown, the sum of the length and the girth, so you have to add the length plus the girth. Length plus, you do girth as capital G. Okay, so the length and the girth cannot exceed 108 inches. And I believe they're going to ask for the maximum, so I'm going to put equals. Suppose that for one such package, the length is 36 inches and the girth is as large as possible. Okay, so the length is set. So I'm just gonna, what I'm gonna do, you can kind of see my board here. I have L plus G equals 108, but they're telling us the length has to be 36. So I'm not gonna use L anymore. I'm gonna use 36 and quickly subtract it off both sides to get 72. The girth has to be 72. So the perimeter of that rectangle, and it could be a square, I don't know. If the width and the height are the same, it's a square. All right. So what is the girth of the package? We already have it.
But it's not a square.
Which one?
It could be.
Which one, Mr. Oscar? Which one do you mean by girth?
The girth is the rectangular perimeter cross section, perimeter of a cross section of the package.
Horizontal or vertical cross section?
They showed you in that picture. Let me share the screen one more time. See it? It's labeled girth. See it? It's that.
Oh, I see. I didn't see it. It's because I.
Yeah, and if you look at it, it's a width. It's two widths and two heights, basically. It's the perimeter of that rectangle. Okay, I'm going to go ahead and stop the screen share here so we can look at the next question. Okay, so we're already done with A. A is what was left after you take away the length. So write an expression for the package's width in terms of H, in terms of height. Well, we know that the girth is made up of 2 widths plus 2 heights equals 72, the girth. But they want me to write an expression for the package's width in terms of height. So you have to solve for W, and then you'll have height, the variable in your equation. Okay, and then I'll answer the second part. So if I'm going to solve for W, I'm going to divide everything by 2. And then subtract H. Questions about that? And then it says write an equation giving the packages. I'm sorry?
And you also do the same for like solving for H, so that H is equal to 36
Yeah.
minus W.
Yeah, you sure can. I'm just following what it asked me to do. Now the volume we know is going to be the length times the width times the height, right? So length times width times height gives me volume. However, we know the length is 36, so I'm going to get rid of that. And we know that the width is 36 minus H. There.
Difference in squares.
This is length, width, height, right there.
Difference in squares.
You see a difference of squares?
36 plus H, 36 minus H.
Where do you see 36 plus H? It's not plus H. It's
Oh,
36.
never mind. Never mind.
Yeah.
Never mind.
Okay, so when I multiply this in, if I'm going to multiply this in, what would I get? 36H times 36 would be 36 squared H minus 36H squared. That's what I would have, equals V. I didn't square the 36 yet. But I mean, there's an equation for the volume in terms of the height. And then it says, what height and width maximize the volume of the package? All right, so the volume of the package must be on a coordinate plane. The volume must be the y-axis. All right, and then
So the
this-
equation would be 36x
And
36.
the x-axis is height. Yeah.
Hey, h, right? And then once we have h, we can plug it back in up here and find out what that w is going to be. So what height and width maximize the volume of the package? What is the maximum volume? Explain how you found it. So I think that what you're going to get here is if you rearrange this, you get v is equal to negative 36h squared plus the 36 squared h. Okay, and
36 squared is 1296.
but that's upside down, right? And and I think that if I put this in vertex form, I'll already know the location. I'll know the location h. I'll know the height. I don't even need to know what the volume is. It doesn't ask for that. Oh, but later on it does. So fine. You see this, a is negative here, which means it's going to be upside down, right? And the y-intercept is 0. It starts from the origin. So it's going to do something like that. Because when h is 0, there's no c term out here to give you some initial height above ground. Okay, so when h is 0, volume is 0. When height is 0, volume is 0. And that makes sense. If the box has 0 height, then it doesn't have any volume. You need that third dimension. You need to have a positive value for each of the dimensions. Okay, so where is this maximum here for the height? The maximum height possible for volume. So then what I want to do is if I can get this into vertex form by maybe factoring out a negative 36, if I factor out a negative 36, then what does that help me to get into vertex form? What does that give me? It gives me h squared minus 36h.
Can you move the camera down a little, please?
Yeah, but that's not vertex form. Vertex form, I need to have h minus a number squared would be vertex form. Maybe you wanted to factor out an h with that. If you factor out an h,
Yeah, I was thinking that.
then you get that. But you do not, it's not squared anymore.
And the a has an h term in it, which doesn't happen in vertex form.
Okay, so you don't have this in vertex form, but what you do have it right now is in intercept form, which is great because the average of P and Q is the location of the vertex, also the x coordinate, right? So while in intercept form, I don't need to spend my time trying to get it into vertex form by completing the square. So to get it into vertex form, you have to complete the square. I don't need to do that because I can get a P and a Q right now. P is going to be what makes the H 0 here, what makes the volume 0. H would be 0 here. Q would be what makes this group 0. What would make this group 0 is if H was 36. Okay? And the axis of symmetry is going to be between my two roots. These would be my roots. It would be the average between 0 and 36. All right? So my axis of symmetry, which would be H here, this is normally x equals the vertical line, x equals a number, gives me that vertical line. Well, but we don't have x in this case, we have h. So h equals a number is the axis of symmetry, right? And that has to be the average of these two roots, 0 and 36, right? So right in the middle is 18, right? That's averaging P and Q. Let's try to recall what we were talking about in intercept form. This is intercept form. So I know that if this is 18, 0, then I know that at the maximum point, 18 is the height. What volume is that going to give me? You just need to plug it in. All right. So I've answered what the height is, 18, and I believe we're in inches here. I can now tell you what the width is. If you go back up here, look, if the height is 18, then the width is 18. So it's got to be, the square is what maximizes. Having the width and the height be the same maximizes the volume. It maximizes the volume, okay? What is the volume? Let's go ahead and plug that 18 back into the problem. Where we
18 squared, wouldn't it be?
11664.
So let's do that. Whichever one seems easiest to plug into. Okay, so 18, here we go. Let's go. So this I know if I plug it in here, I'll get 18 minus 36 is negative 18 times 18 times negative 36. It's going to be positive. So it's 18 squared times 36.
Squared is 324, isn't it?
Yes. So it's 11,664 square cubic inches.
Yeah.
Okay, so
Length is 36, the width is 18, height is 18.
664 cubic inches. Okay, that's a nice little challenge problem to start off with. Any questions about that?
Nope.
All right, so I didn't know what form was going to work. It's nice to know different forms because if you didn't know intercept form, you would have spent extra time trying to complete the square so that you can get it into vertex form, or plug these bigger numbers into the quadratic formula, which is fine. You can do that. There's no problem with that, and you should know how to do that. Okay, but it's actually delightful to use different forms. It feels more free. I feel like I have more freedom in solving it a way that seems interesting to me. Helps me learn it better. Okay.
Oh, but Mr. Rosenthal, why is the axis of symmetry H?
Because we don't have an X and Y. X is H, Y is
Oh.
B in our problem.
Okay.
Yeah. That's the thing. If you keep only learning math and X-axis, Y-axis, you can't really apply it to the sciences unless you start graphing your coordinate planes with the things that you're trying to, the pieces the variables that you're trying to use to solve a science problem.
You can, Mr. Rosenthal.
You
It's
can make
a nominal difference.
You
It's a
can-
nominal difference.
No,
If you put
not.
36x, if you put 36x squared plus plus
not what I'm
36
talking
squared
about.
x, it would be
Yeah, that's not what I'm talking about. What I'm talking about
no,
is
the axes. You mean, right?
no. It's what why did Daniel wonder what that is and where is it? And it's because it's not nominal. The student has to make that last connection with, oh, it doesn't have to be X and Y. I want them to understand that. It doesn't have to be X and Y. It's a relationship between things. It doesn't have to be X and Y.
Oh, and Mr. Rosenthal, one more question.
Yeah.
Why did you decide to find H by using volume?
The question, it says, look at how they directed us through this. They told us to solve for volume in terms of H. So you got this quadratic when you did that. All right.
Oh.
And it had a negative A, which I knew it meant upside down. And then they're trying to maximize volume. What you're trying to maximize is the y-axis. That's something to take from that. If I'm trying to maximize something, you're maximizing along the y value. Okay, so
Yeah.
I knew if I'm trying to maximize volume, I wanted to put volume on the y-axis, and then I look at my equation, oh, volume is in terms of h. So it's like y, a function being in terms of x. F of x is in terms of x.
Oh, okay.
Okay.
Thank you.
You're welcome. And speaking of geometry, check out this next problem.
Yeah.
Go ahead and do that next problem and see if you remember what's true.
Oh, I remember this.
Try to do that on your own. I think you know what's true. The way they laid it out and color coded it, it kind of makes, and what we're doing kind of makes it obvious what you're supposed to do. Even before you read the word problem. I'm not even reading the word problem and I can see what they're gonna have us do based on how they set that up. Two secants or chords meeting inside the circle, something is true of those segments. tomorrow we'll take a quiz on sections 4.1 through 4.5 to see how you're doing, just to check in basically. We'll spend the first half of class trying to do the problems, 30 minutes, and whether you finish or not. And the second 30 minutes will probably be going over them to see how you did and to ask questions. It's like studying together. I mean, all of this is kind of like studying together, but that's kind of like a check-in to see how you're doing. Do you understand it or not? But really, you shouldn't need that. Honestly, you shouldn't need that. The homework, if you're doing the homework, you should be able to check with each other for your answers to see if you're getting the same things. And there are many ways to get feedback. You shouldn't rely on external factors like a teacher to, give you opportunities to check yourself. Learn how to check yourself without somebody else doing it for you. All right? Go seek the answer. Seek corroboration. All right, let's take a look at this problem. What's true about the chords when they intersect inside the circle? What's true?
That the segment of one chord times the other.
They're equal. They're equal.
What do you mean they are? And somebody was already answering, so let them continue their answer.
The one segment of a chord times the other segment of that same chord is equal to one segment of the other chord times the other segment of that chord.
All right, great. Okay, so now I can stop the share screen. So basically in that, you should have set this up. This chord, 3x plus 2, times x plus 1. Those are the segments along the same chord that were split by the intersection. Has to be constant. So that's equal to 2x times the 5x minus 4. Okay, and so now we just need to solve this. So let's go ahead and do that. Why not? All right, so here you have 3x squared. You're going to have 3x and 2x is 5x plus 2. Here you're going to have 10x squared minus 8x. And I am going to rearrange this in such a way that I have a positive a. Okay, so I'm going to have 7x squared. I'm going to move everything over there. Minus 13x minus 2 equals 0.
Would it be fine if we had would it be fine if we had a negative a?
Yeah, of course. Of course. Remember, to solve this, you're finding the roots. You're not finding the entire parabola. Therefore, this does not mean that the parabola is upside down or right side up. You're doing this when y is 0. It doesn't matter. It's all you're finding is where it's crossing the x-axis. All right, you're finding basically a cross section of the parabola, which are 2 points. Cross section of the parabola. Think of that. When you take a cross section of something that's 2D, you lose a dimension. Cross sections lose dimensions by 1. If you take the cross section of a 3D, like the girth, what was the girth?
Square, a 2D object.
It's a 2D, right? So when you take the cross section of 2D, you get 1D, which are points, right? So it makes
Lines, 1D are lines.
Yeah, so it's cool. We're thinking of solving a quadratic as a cross section. If you think about it that way, there's different cross sections you can get. You can either get no solutions where your cross section didn't meet the parabola at all. It could be tangent, your cross section, which means you're only going to get 1 point, or it can be like a secant where it touches it at 2 points, right? So then you get these 2 points, which are one-dimensional each on their own. But that's interesting to think about a parabola's, the solution to it is a cross-sectional.
How do you take cross-section of a point?
You would have, a point has no dimensions, right?
Yeah.
So to take a cross-section of that might be to go into some negative one-dimensional dimension.
I don't think that's possible.
Yeah.
Why not? Why not? It's symmetrical.
Wouldn't that be x to the negative 1? So
Are you saying that the universe is not symmetrical that way? Let's move on.
No, if a point, well, generally point in mathematics is defined as having an infinitely small size, right? How do
Yeah,
you take the
we're talking about we're talking about moving through dimensions.
Yes, but how do you take the cross section of something that has an infinitely small size?
Well, how
Which
many
makes
lines go
no
through a
dimension.
point? Or is every
Infinitely many.
okay? And from a single point, can you draw a line perpendicular to that point?
Yes, you can.
How can you?
Well, first you'd have to extend a perpendicular.
It has no mass.
Yeah.
How can it be perpendicular?
Or you'd have to get
A line including, yeah, it would have to be a line including the point in order to make it perpendicular.
Okay, so as long as it includes the point, all lines that go through it are perpendicular to it. All of them are.
Yeah.
Yeah, so something's going on at that point.
And tangent as well.
But
Wait a minute.
The point is still a conceptual. It's still a conceptual
location.
location. Yeah, it's
But
not a thing. It doesn't have a size.
Well, I think it is a thing. It's a zero-dimensional thing. Just like 0 is a number, right? You can't say it's not a thing. It is a thing, and it has properties. Okay, anyway.
Cross section of a point would be 1 over x.
Sorry, we have to move on. I'm sorry. Okay, so let's solve this. I don't see any perfect squares, so I'm just going to go ahead and multiply a and c. I'm going to add up to -13. That came together quite nicely. So 1 and -14. I'm going to split this apart. I know David probably wants the -14 with the 7, but he's not going to get it.
You're not nice to me.
You did want that, didn't you?
It makes no sense that way.
But not dollars. Okay.
It does make more sense.
It doesn't
Well,
matter.
actually, yes, it does.
Don gets me.
I want to show you that CERN gets me. I'm just copying that and then I check. That's how I do it. Equals 0. Notice I keep my 0 there the whole time. Okay. Check it. -14x, yes. -2, yes. So we're good. So I get 7x plus 1. X minus 2 equals 0. So x can be -1/7. Opposite of that over that. Opposite of that. Now, look back at the context of the problem. It's in a circle. These are lengths. In a circle, you can't have negative values. So this -1/7 is extraneous. So x has to be 2. And how can I check it? You can plug it back in. If it's x is 2, let's go back a little bit higher here. If x is 2, you get 8 times 3 is 24. And then if x is 2 is here, you get 4. And this is 10 minus 4 is 6. And that's true. 8 times 3 is equal to 4 times 6. Okay? Questions?
Just about the quiz, will we submit it to Schoology tomorrow, or will
Submitting
we
it.
just...
Not being submitted.
Oh, we're just gonna fill it in and check answers?
It's just class. It's just like me having you do this problem right now.
Does it count for a grade?
No.
Oh, okay.
All right, let's move on. Solve quadratic equations by finding square roots. Great. Okay, take a look at that, and I'm going to read this out loud. Okay, so we're on 4-5. This is the middle. After this, we're halfway done with this chapter. Okay, a number R is a. Oh wait, there's something about Jupiter there. Let's see. Is it anything interesting? No, they don't give you any information about it. They just put Jupiter there for some reason.
Exercise 39.
Saturn.
It looks like Saturn.
Yeah, it looks like Saturn.
Oh, wait, no,
That's
the planet
Saturn.
looks like Saturn, the rings look like Jupiter. No, sorry, the planet looks like Jupiter, the rings look like Saturn.
Yeah.
That's Saturn.
All right, guys, let's not get carried away. Here we go.
All right.
So am I sharing screen? Yes. Okay, here we go. A number R is a square root of a number S if R squared is equal to S. So try to think of it that way. Okay. A positive number S has 2 square roots. One is the positive and one is the negative. All right, because if you think of squaring something, if you square a negative and you like +5 and -5, if you square them, you're going to get 25. All right, All right, so for example, oh, it even gives you an example. 3 squared is 9, but also negative 3 squared is 9. So the 2 square roots of 9 are plus or minus 3, right? So the positive square root of a number is also called the principal square root. All right, so that, I mean, that's, you know, the name of it is not super important, but just so you know that the principal square root is the positive one. Okay, so the expression square root of s is called a radical. That symbol that you've seen many, many times now is a radical sign. The number s beneath the radical sign is the radicand of the expression. So s would be the radicand. Now for your properties, it's really important that you look closely at these properties because students forget that this is true. Look at the product property and look, A and B must be greater than 0 for this property to work. Because if it's 0, the 0 property of multiplication is going to take over. It's just going to make everything 0. And if it's negative, well, that's for another section we're going to get into on complex numbers. So let's save that. Anytime you feel like getting off onto that tangent, no pun intended, hold off on that because we're going to do that anyway.
Wait, Mr. Rosenthal.
Let me just finish. So the product property means that if you have, it says it there, so I don't know how much I need to do this, but if you have A times B in a square root, sometimes it is advantageous to split them into 2 separate square roots. Okay, and so that's true. That's a property of square roots. Same for quotient, of course. If you have A over B inside the radical, that's equal to if you split it into 2 separate ones. Or if you have 2 separate ones, you can put them together into a single one. So I can go from this one to that one. All right?
Wouldn't couldn't A and B be negative if they're both negative and they're in the same group? Like the square root of -1 of -1.
Yeah, okay. So, but what this is saying,
Square root of 1.
This property is a property is something that's always true, right? So for this to always be true, right, you would want both of them to be greater than 0, because if you don't set a rule for that, then there could be an opportunity for A to be negative and B to be positive, right? So then the property wouldn't work. Not with real numbers. It wouldn't work with real numbers. So the way to guarantee that is by making everything positive.
What if you just said that they can't be 0 and they have to have the same sign?
That would work if they're both negative. Yeah. Yep, that would work. Okay, so you can use the properties here to simplify expressions containing square roots. Most of you know how to do this, but some of you need work on this. So I'll give you some time, but I don't want to spend too much time on this stuff. You really need to know how to do it, though. No radicand has a perfect square factor other than 1. Okay, so a square root expression is simplified if, let me go back to the share screen. When do you know you're simplified? No radicand has a perfect square factor anymore. There are no more perfect square factors other than 1. And there's no radical in a denominator. So that's where you learned how to rationalize the denominator. And you've seen me do it a couple times. All right, so here we go. They already have those problems for you. So what I'm going to do is I'm going to put up the practice problems and leave the sample problems up above for you to do. Okay, everybody take a couple minutes and do 1 through 8. You can use the sample problems above if you have trouble. And then we'll talk about them. if you look at the samples, look at what they're doing with that 80 there. They've located a factor that is a perfect square factor. And that, you know, your ability to do that quickly is going to be based on your experience with factors and multiplication. If you are experienced with multiplying lots of different types of numbers, then you quickly see 80 and you pick out the 16. But if you weren't aware that 16 times 5 is 80 right quickly like that, if it was oh yeah, I think that kind of thing, these could take some time. So some people are going to do these much faster than others when you're able to pick out perfect square factors. Okay. All right. Oh, there's something blinking. The chat. There's some stuff going on in the chat here. Oh, people are putting answers. Okay, that's fine. Can't see because of glare. What do you mean you can't see? Oh, that must have been. But right now I'm sharing a screen, so there's no glare. Do you think we'll finish the chapter before the end of the year? Oh, yeah. Oh, yeah. The 15-week grades are about to come out. That gives us several more weeks before we're done with all this stuff. So, and we're going to do this all the way up until the last day. We're not going to stop. We're going to keep going.
Last day of school.
The what?
Last day of regular school.
Last day
That's the
of
date
school,
that's
we're
been set.
doing math. We're going to do math that day.
Oh, excellent. I was just wondering, are we going to end at the same day as a regular physical school?
Yeah, as far as I know.
Are we going to restart at on the same day as regular physical school?
Yes, they've announced that we're definitely starting on August 18th.
Oh, that's great.
Wait, what?
Okay, everybody, let's stay for office hours if you want to discuss that stuff. Who needs to see number 1?
Probably nobody.
No, that's not how we do it. We have a routine for this. If you need it, I'm waiting for a yes.
Yes.
Okay, because there's a judgment in that, by the way, when you say probably nobody.
Bye.
Yeah, there is. I do not like it when people do that.
Yeah, let's just, but we're not aware.
And I'm judging,
David.
whoever said that with that statement.
Yeah, exactly. So we're not always aware of our judgments coming out.
David,
That's
we
good.
all already know my math skills are not good at all.
No, come on now. All right, now here we go. The root 27.
Ian, you're not alone.
All right, guys, here we go.
They have to be good, otherwise you wouldn't be in the school.
You guys, no more. Thank you. Take a look at root 27. What you could do is, if you don't see it, just list factors of it. Any factors you can think of. 3 times 9. You've already located your perfect square right there. So what you do is you're splitting it into those two. You're splitting root 27 into 2 separate roots. One is a perfect square. You can take the square root. The other one's not, and you leave it. And you're done. And I'm using the property.
Yeah.
Questions? Okay, who needs to see number 2? You guys need me to put it back?
Yes, because I don't know what number 2 is.
Okay, you need to have the lesson pulled up somehow on the side. Either on another device or printed out or something like that would be helpful for you. Number 2, anybody? Give you time to say yes. If I don't hear a yes, I'll go to 3. Number 2, by the way, the perfect square, that's 49. That's 49 times 2. So the square root of 49 is 7, so 7 root 2. Who needs to see number 3?
Me.
Okay.
Me.
All right, great. So it's the square root of 10 times the square root of 15. Okay, now if you notice, this one is rad 2 times rad 5 times rad 5 times rad 3. Well, look at rad 5 and rad 5. When you multiply those together, you get rad 25. Rad 25 is just 5. So when you multiply a square root times a square root of it's the same, it's just the radicand is all that's left. Okay, so then you get 5, just 5. Rad 2 and rad 3, you want to form them back together to make rad.
Rad 6.
Okay. Number 4.
Yes.
Got it.
Oh yeah, that one was interesting.
I need to order a new thing of markers. Okay, rad 8 times rad 28. Well, this one already has a perfect square. It's rad 2 times rad 4. You can hold on to it, but maybe you can get another rad 4 out of this one, which you can. Rad 4 times rad 7, right? So if I have those, that's just 4. Then you put those together and you get rad 14. Number 5.
Me.
Me, does that mean yes?
Yes.
Jess. So the whole thing is in the radical. If you split it, you take the square root of the top and the square root of the bottom separately, and you get that.
I feel very stupid now.
No, don't say that. Number 6. Can rad 15 be simplified anymore?
No.
No, because the factors are 3 and 5, and that's it. So there's no repeats. But
Rad 15 over
You can
2.
do the denominator.
But the denominator just becomes 2. So it becomes rad 15 over 2. Not rad 15 over 2, but rad 15 over 2. All right.
Yes, that's the difference.
Number 7, rad 11 over 5. Number 8, 6/7. All right, moving along. Okay, rationalizing the denominator. So when you have like the square root of 5, for instance, on the denominator, you have an irrational denominator. And so part of the definition of simplification of radicals is that you don't have an irrational denominator. So take a look at this chart. Form of the denominator, multiply numerator and denominator by the square root of b.
Oh yeah, because that's a difference in squares. A squared plus b squared. A squared minus b squared.
Actually,
It should come out to be a squared
Guys,
minus b.
You guys, hold on. All right.
the other one is still known as a conjugate, though, isn't it? Not
So
just
this is where
imaginary.
conjugates actually comes in to the algebra.
Yeah.
This is where that word comes in. And if you look there, that second paragraph, a plus b, and not even rad b, a plus b and a minus b are conjugates. Okay, but here, a plus root b and a minus root b are conjugates. Okay, those are conjugates.
Because the product ends up being a rational number.
Yeah, so let's go ahead and
You can use it to evaluate limits too. I found that out yesterday. You can multiply both sides by a conjugate.
Just look at what happens when you multiply conjugates. One is plus, one is minus. You're going to get a difference of squares. That's what happens. By eliminating your middle terms, what happens is you just get to square the first terms, and you get to square the last terms, which is great, and it's a difference. And squaring a square root is just going to give you that.
Look, it's a difference of squares.
All right? So that's
same as the difference of square roots.
So if I have this as a denominator, I know I can get rid of the radical by multiplying by the conjugate. Now, you are going to have to account for that algebraically. So if I take something of value, let's say x, and I want to rationalize it It does not mean I want to change the value of it. So
You need to multiply it by the conjugate over the conjugate.
what you're going to do, you're basically multiplying by 1, which is the identity property. It's the multiplicative identity. When you multiply something by 1, you are not changing its value. But it's not going to look like a 1. It's going to look like something over itself.
You do that when you're adding fractions.
Exactly. And so when you're multiplying by something over itself, you know that even though it looks complicated, it's really just multiplying by 1. And the reason we do that, why would you want to do that? Well, you would do this to multiply to its conjugate so that you can rationalize the denominator. And that's it. And that's all.
Ax minus x root b over a minus root b.
That's all we're going to do right now. So it should be pretty straightforward. Okay, go ahead and rationalize those. See if you can put that together. I could sense my markers reaching old age. I can feel it. You can feel it. Even though I'm still getting it, you know, it's still getting the material onto the board. You can feel it's not as vibrant.
Are those markers refillable?
No.
Oh, that's too bad. I guess in old age, they don't have anything to look forward to. To which to look forward, sorry.
The markers? They're inanimate. They don't look forward to anything.
Yes,
I agree.
I was simply personifying them for a joke.
But you're not a poet, are you? I thought you were.
No, I don't.
That's why nobody commented on his poem.
Nobody is.
That's why nobody commented on his preposition poem.
What, Mr. Rostow?
I thought you were too objective for poetry. Okay, here we go.
Well, I never said I was a poet. I was simply making a comment.
I don't know. Maybe there's a poet inside somewhere. Okay, take a look at this.
Not.
Separate them.
Yes.
Then that's an irrational denominator. You can't have that and still be in simplest form. So we multiply by 1, which keeps the value the same. We don't make it look like a 1. You make it root 2 over root 2. And what that's going to do is it's going to give you 2 on the denominator. On the numerator, you have to change it to root 10. Questions? No? Okay. When you get something a little bit more complicated, this has a rational part to it and an irrational part to it. Some students just learning this want to just multiply by root 2 over root 2. But you're going to have to distribute it here, and you're going to get 7 root 2, and you're going to still have a radical on the denominator. Okay, so you don't want to do that. What you want to do is you want to multiply by the conjugate. 7 minus root 2 over itself. Now, on the numerator, you're going to get 21 minus 3 rad 2, because you're going to distribute.
From the bottom, I think you get 47.
It's just square the 7 minus square the root rad 2, which is 2. And that's
47.
47. So you get 21 minus 3 rad 2 over 47.
Yeah.
Questions about this? Pretty straightforward. I believe you covered that in Algebra 1, right?
Yes, we did.
Nothing new here. I apologize that there's nothing new. Okay. Solving quadratic. What this is used for, by the way, they're just making sure you have these prerequisite skills so that you can use to solve quadratic equations. And you can use square roots to solve some types of quadratic equations that are less complicated. Plus or minus, I think you guys got that. I'm going to move a little bit forward here. You guys can go ahead and solve this next one quickly. Go ahead and solve that. Don't use the quadratic equation Use square roots. Please. I beg of you. All right, you had a head start.
Yes, I guess we did.
Okay, so I'm going to subtract the 5. Okay, you see that? I'm going to subtract 5. So that came out nicely. Take the square root of both sides.
Why you keep
Wait,
doing
can
it
you
as
just divide
36 over 3? Why don't you just
First.
Why wouldn't you just simplify it to 12?
You can.
And look at it up there.
You can.
You just have to do the extra work of rationalizing the denominator.
It doesn't matter. You choose whatever way you like. What is the square root of x squared, everybody?
X.
No, it's not.
I don't know.
This is going to be 6 over root 3. And then you have to rationalize the denominator. It's much less work.
No.
Much less work to.
This is the square root of x squared.
Okay, yeah, but
Over here, you can simplify it to 12, right? Which is rad 4 times rad 3, which is 2 rad 3. Okay? Or you can rationalize the denominator and get 6 over rad 3 and then multiply by rad 3 over 3. Rad 3 over rad 3. Okay, but this is what I'm getting at here. Why is that the absolute value of x?
Because if x is negative, then you square that, it becomes positive, then you square root that, and then it becomes positive x.
By the way, if you have this, not the same thing. X can't be negative here, but it can there. Cannot here, it can here. So having the squared outside, you would think, oh, isn't that the same thing? No, it's not the same thing.
if you go in
No,
Decimals,
because-
that's what it looks like, yeah.
Yeah.
No, because in that case, what you're doing is you're squaring it after you have the square
Right,
root of x.
right.
The second case,
Is it the square root symbol is a grouping symbol?
It affects the domain. The domain
Yeah.
is what x can be.
Like if you go on Decimals and graph y equals square root of x squared, then you get a parabola, I think. But
Yeah.
no, you get a straight line.
So you're lacking symmetry here, aren't you? You would think
Yeah.
they are totally the same thing. And they're not.
The black one, you only get half of it.
Mm-hmm. Because you lose out on your domain, all the negatives you lose. Here, you get everything. Okay, so x can be all the negatives and the positives because you're going to square it anyway. Then you take the square root.
It's a black one. If it's
Okay.
if it's negative 1, they don't do I,
Let's
and
go
so
back.
they won't even go to I, even though they're just gonna go right back anyway.
I'm so sorry, we're running out of time. Normally, I do like the insight and all of that stuff, but just for a matter of time, we're going to kind of press forward here. I'm so sorry. Okay, so the absolute value of x is what the square root of x squared. I know Mr. Knaus doesn't teach it that way, but that's what it actually is. Okay, so x here can be negative or positive this, and when you take the absolute value, you get this. So what he's doing is he's skipping right to there. He's skipping this intermediary step when he does that. I just wanted you guys to know that. So then x could be plus or minus. It could be positive or negative 2 rad 3, and that's critical that you understand that. Or you're going to miss half of your solutions in the future. Okay? All right. Dee. Oh, loading. That's the solution to it. Oh, then you have this one. Go ahead and answer that like you're taking a standardized test. I thought we were going to finish early so I could play you the Carl Sagan.
We could play it after office hours, and whoever wants to stay can stay.
I kind of wanted everybody to see it.
Everybody can stay.
Don't you guys have something to do after?
Yeah.
Yes.
Graders have
Breakfast.
Breakfast.
after.
I
Yeah,
have
breakfast and watch.
packing up this
Another class?
semester.
Do you all have another class?
Yeah, I've got
Yeah.
chemistry in 30 minutes.
But at what time?
10.
10.
Oh, well, you could watch a 10-minute video.
I have something else to do though.
Wait a minute, what class?
Chemistry.
They're in
Wait till I-
8th grade.
They're in
What
what?
will you be
Eighth
thinking?
grade. 8th graders, different schedule than you.
Oh, okay.
By the
Then
way,
all the
Zig, I
7th
finished-
graders can stay.
Zig,
No,
I finished
I'm going to wait until there's an opportunity where everybody can stay and watch. Okay, here we go. Multiply both sides by 5. And then you get z plus 3 squared is equal to 35. Now, the same thing is going to apply here. When you take the square root of an unknown complete value, some of it is known, but the whole group is not known. So it's still an unknown squared. The unknown can come out to a negative value. It can come out to a positive value. So the square root of any unknown squared has to be the absolute value of it. See that? And you cannot simplify the square root of 35 any further. Okay, so what that tells me is that z plus 3 can be negative or positive this. And then you can subtract 3. Negative 3 plus or minus. And that's 2 answers right there. Usually this is the axis of symmetry right here. Z is negative 3 is the axis of symmetry. And then you go.
And those are the roots.
Yeah, and then you go root 35 to the right and root 35 to the left because it's an axis of symmetry that you're going to have the same distance to the right as you do to the left to get to the 2 roots.
And this parabola is 1/5 z squared plus 6/5 z plus 9/5.
Thank you.
But Mr. Rosenthal, where did the 1/5 go?
No, minus 26.
Hold on. I multiplied by 5 in the beginning on both sides.
Oh.
Questions? All right.
Could we have solved that quadratically?
Of course. Let's see, is there anything after that practice? There is stuff after that,
Interesting.
which means we're not going to finish in time.
Oh,
Oh.
no.
So several things. That's okay. We're not in a rush. Remember that. We're
How
not
long is the Carl Sagan video anyway? We have 5 minutes.
probably 10 minutes. So there are a few more things I want to cover. So maybe we hold the, I know, let's finish this tomorrow, then watch the video, and then we'll take the quiz Wednesday.
Yay.
Yay.
All right.
I'm fine with that.
I'm fine with that.
Oh, David, you're starting to learn.
Dismissed, everybody. I'll see you tomorrow.
Are you
Office
fit
hours-
on?
Office hours.
I
Thank
said
you.
I said you're starting to learn, David.
What?
I said you're starting to learn.
Beginning to learn?
Yeah.
What do you mean? I like flatlands as much as anybody else.
No, that's not what I meant. I'm saying that I'm saying that you're starting to learn not to jump up and down with glee as soon as Mr. Rosenthal announces that the test is going to be pushed to an earlier date than anyone expected.
Later date or earlier date?
Earlier. He gets happy when the
Hey,
test is
hey,
close.
you don't know that I'm not jumping up and down with glee.
It doesn't
No, I mean I don't think you, well, you see, you were happy when he pushed it up to Wednesday. That's the point.
Well, if it's a substitute for flatland, then of course I am.
Mr. Rosenthal,
Yes.
I have a question for you.
Okay.
On the homework, there was a problem where we needed to prove
I was in 4.2.
It was okay. Here, let me see the problem.
Yeah,
Was that the one?
What section was it? 4-2?
Was that the?
Yeah, the last
Was
one,
that
the challenge problem, the one that you
Daniel, was
solved.
that the derivative one?
Yeah, the one that you solved with the derivative, and the one that David solved with I don't
It
know
was
what.
from 4-2, right?
Mm-hmm.
Okay. The challenge problem with that flying fish?
No.
No, the one at the end of
in the
4-2.
in the homework.
Popcorn? Oh, in the homework. Challenge. Number 50?
Yeah.
Right. Y equals ax minus h.
In standard form. And y equals x minus p, x minus q in standard form.
In standard form. Knowing the vertex, okay, so let's do that first. So standard form, I'm gonna have to square this.
Yeah.
So this will be x squared minus 2xh plus h squared plus k out here. A is gonna go in there. Ax squared minus 2axh. No, I want the h to come before the x. Plus ah squared plus k. Okay. And then that would be standard form. All right. Knowing the vertex of the graph occurs at negative b over 2a, show that the vertex of the graph of the first one occurs at x equals h. Oh, great. Okay. So we want negative b over 2a, right?
Yeah.
So this is b. Oh, this part here. Sorry. And here's a right there. All of this is the c. So this is c, this is b, this is a. Okay. So then you know the x coordinate of the vertex is at negative b over 2a.
Okay.
Okay, b is negative 2ah, and a is a. These make positive.
Yes, a is x.
A's cancel, and you get h. There you go. You just proved it.
Yeah, that's the axis of symmetry, h.
That's
We
it.
already knew that because h is the x
Well, no,
coordinate of the vertex.
we're showing that this form simplifies into h. So we know
It's the same thing. Yeah.
it proves that h does the same thing as negative.
You could have done it with derivatives.
Okay.
Oh. Oh, and Ms. Rosenthal, can you do it with
could have done it with
derivatives?
derivatives.
Do it with derivatives. Okay. So if you want to do it with a derivative, you want to show, what are you trying to show with a derivative? What is a derivative? It's a slope, right? The slope
of a point, yeah.
Yeah, and that's when the slope is 0, you are at a maximum or minimum point. And what is the vertex? The vertex is the location of the maximum or minimum, right? So if you
find the vertex,
finding the slope is finding the slope and setting that slope equal to 0 is finding the flat line that goes through the vertex. All right, so let's take the derivative of this. All right, now all of this is with respect to x, the change in y with respect to the change in x. That means anything that's not an x is a constant. It's treated as a number. So even though you see a squared here, all of this adds up to a number. And numbers are multiplied times x to the 0. And the way you take a derivative is that exponent of 0 gets multiplied to that, and it gets rid of it. So that all goes away. Okay? This becomes 2ax.
Mr. Rosenthal, the connection is very bad.
The what? Your connection's bad?
It says you have a low bandwidth.
Oh, the connection. It's pixelated.
Okay, let me stop my video for a second.
Is it just me?
It says that you
or is anyone else getting that problem?
Does it say that now that my video is stopped?
Yeah, it says that you have a low bandwidth.
Even now that my video is stopped?
No.
It says my internet is unstable.
Yes,
Can you hear me? Can you hear me?
Yeah, we can.
Yeah, we can see you too, but it's still fuzzy.
Well, there's not much I can do about it.
It's okay.
But you can see how I got this? Okay, now the exponent here is...
Okay, so the thing that you...
Hold on.
The thing you crossed out, why did you cross it out?
Because if you...
I have to go. Bye.
Bye. All of this is equal to some constant number. There's no x.
Bye, David.
Only x and y are the variables. All the rest of them represent possible numbers. So ah squared plus k, there's no x or y in there, right? So that's all just some number. And whatever number that is, you can multiply it to an x to the 0. What is x to the 0? Daniel? What's anything 0?
1.
1.
Oh, I mean 1.
Yeah, and the derivative of that...
I thought you meant 0 times x.
No, x to the 0. When you take the derivative, you take that exponent and multiply it to the coefficient here, right? And makes it 0. Okay? So that gets rid of it. It gets rid of taking the derivative, all constants are always go away. X to the 1 gets multiplied to the negative 2ah, and then that becomes x to the 0, which is just 1, and then so you don't see it anymore here. The x to the 2, that gets multiplied, becomes 2a, x to the 1 is still there, so you still have an x. And that's the slope, and we wanted to set that equal to 0 at the vertex. All right, so now solve for x. When you solve for x, you add 2ah to both sides. Divide by 2a, and look at what you get. X is h at the vertex.
Ta-da!
Ta-da! Okay, and then...
Wait, so what is the derivative in this?
The derivative is this. The derivative of the standard equation here. The derivative is the slope of a tangent line.
The derivative is just...
To your graph. So at your maximum point or your minimum point, the tangent line slope would be 0 at the maximum and minimum points. Remember that if I have a parabola like that, if I find the slope of a line tangent there, it's going to be some positive slope. If I want to find the tangent line, let's say there, randomly, it'll be negatively sloping. But I don't know what it's going to be. But here I know what it's going to be. It has to be a flat. It has to be 0. Not only that, where is that point? That's the vertex. So because we know the vertex has to be when the slope is 0, then I can take the slope is 0. I know what the slope of a line tangent is. It's the derivative of this. So the derivative, we follow the rules of a derivative to get this, and we know it's 0 because it's flat at that point. At other points, it's not, but at the point we're interested in, it's 0. That line has to be flat at a minimum and at a maximum. The slope of it has to be 0. So then once I have that, I can solve for x, and it says x has to equal h at that point. At another point, x does not equal h. It equals something else. Okay, and then you would do the same thing with the other problem, which is in intercept form. So let's see, if it's in intercept form, then you have what? Y is equal to a x minus p, x minus q, and we want to write that in standard form and then show that the vertex location is going to be at the average of p and q. Okay, so x squared, you're going to get minus qx minus px plus pq. And you're going to multiply a to everything. AQX minus APX plus APQ. Okay. All right. So that's going to be standard form. But wait, you want to factor this out. So watch this. AX squared. Take out an x, and what are you left with? You're left with, oops. Take out a negative x minus AQ plus AP x. There's your B right there. And if you don't believe me, multiply it back. X times AQ is AQX. X times AP is APX. And that's plus, but since you're subtracting it, it will be minus both of them like you see there. Okay? Plus APQ. Here's your C. This is your B. This is your A. The vertex, we know, is when x is equal to negative B over 2A. Okay? What is B? B is negative AQ minus A. It's negative of that whole thing. So what I could do is I can do that. B is negative that group. And you're supposed to take negative B, but B is already a negative group. So negative group over 2A. So that negative makes it positive. So that's positive AQ plus AP. Factor out an A, and you just get Q plus P. Here you have 2 times A. And then the A's cancel out. And look at what you have. X is equal to Q plus P over 2, the average of Q and P. You still there?
I think he is. He's registering me.
Yeah, I'm here.
Okay, and then the calculus way of doing it, let's take a look at that. Take the derivative. What's the derivative here, Daniel, only of this term? 2 times the A. And remember what the derivative is. It's dy, delta y over delta x is a slope, change in y over change in x. 2a x, okay, what's the exponent here? 1, it's 1 times this whole thing, minus aq plus ap. And then that goes to x to the 0. It's gone. And this is a constant. It's gone. When this is equal to 0, you are at the vertex. Okay? Now what's going to happen is you're going to have to do some factoring, right?
Yeah.
Maybe you can even add this to both sides, right? So 2ax is equal to, add this group to the other side and factor it. Now divide by 2a.
Yeah, I believe that's what I did.
And you get q plus p over 2. Same thing.
Just fast.
2x.
Okay?
Wait, sorry, why'd you do over 2a again?
Here, solving
for x.
Solving for x, you get rid of the 2a by dividing by 2a on both sides.
And the other one, you just have to do it because to keep them equal.
Where are you looking? This line or this line?
Oh, yes. So that one I understand why, but then why for the a cubed plus p over 2a? Oh, you just took out the a, never mind.
Yeah, when I added this, I also factored an a out.
Okay.
Other questions? All right, so that's a good problem. I wish I would have done that in class. That was a great problem.
Thank you, Mr. Rosenthal. Have a good day. See you tomorrow.
You betcha.
Okay, thank you, Mr. Rosenthal.
You're welcome.
Bye.
Bye. Anybody else? Question?
I'm trying to figure out what I did wrong on my chapter 12 test.
Oh, what did you do wrong?
I got a 20 out of 40, and apparently I messed up on half the problems, but I double checked all of them right now. It doesn't
Wait
look
a
like I
minute.
messed
You
up
got a
on any.
20 out of 40? You should have gotten a 40
Yes.
out of 40.
Yeah, I got a 20 out of 40, so I'm like super
No.
out.
Oh, no, that's a mistake. I'll fix it. Send me a message, please.
I already sent you a message.
I'll fix it. It's supposed to be 40 out of 40.
Okay, I was like, oh my god, I was freaking
Yeah.
out so bad.
Look at what it says, problems missed. Does it say problems missed?
Yeah, it says
Probably only
problems.
one thing, right? Or two things that are half or something like that. Right?
Yeah, it says half.
On just like one problem, right? Or two problems?
Actually, it doesn't say which problems are missed. It just says problems missed, and then in parentheses, half.
It doesn't say the number and then half?
No, it doesn't say any of the numbers.
That's strange. Then it should have been a number with the parentheses half after it to tell you what number you got half on. So just write that for me, and I'll go ahead and correct that. That's a typo.
Okay,
Yeah.
thank you, because it lowered my grade 8%.
Yeah, don't worry about that. It'll get fixed right away.
Thanks.
Uh-huh. Anybody else? Tiela, are you there? Russell, are you there? Not there? You can chat that you're there.
Hi. Thank you
Hi.
so much.
You betcha. You guys doing okay?
Yeah, thank you.
All right.
How are you?
Good. Do you have any questions for me?
No, I think I'm doing pretty okay for now.
Okay, we're gonna have
I'll
a
get you today.
quiz soon. Now you heard that, right? A quiz soon?
Yeah, tomorrow.
Not worth any credit though.
Okay,
Actually, we're
thank you.
postponing it till Wednesday because we still have a little bit left. How's the algebra? Is the algebra okay?
Yeah, it's pretty okay. I meet with my tutor once a week.
Excellent. Okay. Let me know if you have questions. You can always stay for office hours.
Thank you again.
Okie dokie. Russell, do you have any questions? Are you there? No? All right. I'm going to go ahead and end session.
Yeah, I'm here.
Oh, you are there. Okay, great. Did you have any questions for me?
Yeah, not really, no. I just stay here until the end of office hours to see if anything that I want to know comes up.
So, because interesting things can come up in there, huh? Are you learning the calculus that we're doing?
Yeah, it's a bit hard to understand, but I try.
Yeah, get into that conversation next time and talk about it. Ask me a question. How did you get that? All right. Maybe I'll go and look up the proof again and I'll relearn how to do the proof to show everybody. But anyway.
Okay.
All right. Well, then I'll see you tomorrow.
See you.
All right. Bye.